So, as we go back in this direction, now of course we know that the object was projected from a height of 11 feet. However, if you did go back a few, actually 0.1 seconds, that's another spot where this parabola basically mathematically intersects the horizontal axis. So there are 2 points here and here. Now, sometimes they don't all make sense in the practical scheme of things. Like this one, for example, probably doesn't mean much to us, but it is one of the possible solutions. Now, also take an interesting feature here is that if you look at this point 3.125, these horizontal intercepts are equidistant from the x value of the vertex. So negative 0.1 is equally as far away from 3.125 as 6.35 is. So this distance is the same as this distance here. Okay, so let's ask another question. So what if we wanted to know, I'm going to skip frames, what if we wanted to know when will the object reach 110 feet? So we always want to think about this practically first before we start answering these types of questions. So what I do know is the vertex and the maximum height. So I know that at some point over the course of time, the height has been at 110 feet. So maybe if this is 110 and I go over to figure out where that what time that happened at, there's one time there where it's soaring above 110 feet, and then there's one point where it comes back down and dips below 110 feet. So I'm going to find these 2 times. If you think about them as x1 and x2, then these are the points that I'm going to be able to find. Okay, well my equation is this guy here, negative 16t squared plus 100t plus 10, and I want to know what is the time when the height is 110 feet. So I'm going to replace h with 110, and I'm going to try to figure out what t is. Now again, the same problem holds that I'm not going to be able to isolate stuff here because if I go about isolating, I'm going to notice that I can't separate the t and the t squared, that I can't branch out the t. So this requires me to use the quadratic formula. Any equation that you're trying to solve that equates to a single value and is quadratic on the other side, then this can be done using the quadratic formula. Okay, but the quadratic formula says if the equation is of the form 0 equals ax squared plus bx plus c, then you can use that formula. But there's 110 on this side. So that's not a problem. What we'll do is we'll subtract it away first. Subtract it away from both sides and combine like terms. So this is 0 equals negative 16t squared plus 100t, and negative 110 plus 10 is negative 100. And now I do have it of the form 0 equals ax squared plus bx plus c. So a is negative 16, b is 100, and c is negative 100. That's what I have when this equation is 0 on one side and then a quadratic on the other. So according to quadratic formula, to figure out what value of, in this case, t satisfies this equation, we're just calling them x and y because I know people are used to calling them x and y. To figure out the time, I would plug it into my formula all over 2a. And rather than to do this by hand, I am going to do it in my calculator. So this is going to have 2 solutions. It will be x equals negative b, which is 100, plus the square root of 100 squared minus 2 times negative 16 times negative 100, all divided by 2 times a, which is 2 times negative 16. And then I will also have the same thing, but with x equals negative 100 minus all that stuff over 2 times negative 16. So in my calculator, what I will enter in is I'll do the plus 1 first. So I'm going to open up a parenthesis for my numerator, and in there I'm going to type in negative 100 plus the square root of, and now notice it opens up a parenthesis for everything that goes under the square root. Whoops, I'm going to type in everything just the way I see it. Parenthesis 100 squared minus 2 times parenthesis negative 16, etc. So I'm going to do 100 squared minus 2 times negative 16 times negative 100, close that parenthesis, close the square root, so now I've just closed the whole square root, and now I've got to close my numerator, so my calculator knows that this whole thing is my numerator. Divide this by, parenthesis, 2 times negative 16. Close that parenthesis for my denominator, and hit enter, and I get oops, slight mistake here. This should not be minus 2ac, it should be minus 4ac. So I just goofed when I wrote this down. So this should be minus 4ac. And so all I've done is I've changed my 2 to a 4, and make this plus, of course. And so that gives me an answer of 1.25. So that's just one of them. To get the next one, I'm going to hit second enter, and what that does is it pulls up my last entry, and now all I have to do is go change my plus sign to a minus sign, and just that easily we get the second solution, which is 5. So I have two values. I have 1.25 and x equals 5. Going back to my graph, what did I figure out? Well, that started off with the equation 110 equals, and I figured out that at time 1.25 and time 5, both of those times will result in a height of 110 feet. So I can write these as ordered pairs. 1.25 seconds, 110 feet. 5 seconds, 110 feet. Both of these situations result in the same solution. Well, now let's suppose we wanted to ask, when will its height be 200 feet? Before we even begin to solve this, we mentioned earlier that sometimes it's possible to have no solution. Okay, well, when would it result in no solution? Well, first of all, this is what our parabola kind of looks like. And we know that the maximum, which is a big deal, occurs at 3.125 seconds and results in a maximum height of 166.25 feet. Okay, well, to answer this question without doing any work at all, our answer would be never, because 200 is somewhere way up here, and our maximum value is achieved at 166.25. Well, how would algebra steer us clear of any logical problems? Well, we would be answering the same type of question. 200 equals negative 16t squared plus 100t plus 10. Again, this is a quadratic equation on the right hand, or quadratic function on the right hand side of the equation, and so we can't just try to isolate t in the way we normally would. We have to resort to quadratic formula. Well, there are other ways, but we will resort to that. So we have to get the left side clear, get it equal to 0 in order to use quadratic formula. So we get 0 equals negative 16t squared plus 100t. Negative 200 plus 10 is 190. And this would result in A equaling negative 16, B is 100, and C is 190. And so we get x equals, and then my formula, negative b plus or minus the square root of 100 squared minus 4 times a times c, all of that divided by 2 times negative 16. Okay, so I'll of course have the x equals negative 100 plus that stuff, and I'll have x equals negative 100 minus that stuff over 2 times negative 16. Alright, well, all I'm going to do is I'm going to modify this equation. So I'm going to hit second enter since I already have used this equation once, and I'm just going to change my minus to a plus, and I'm going to adjust the value of c, which is not negative 100. In this situation, c is 190, negative 190, excuse me. So I will change this to 190, and that saves me from having to enter the whole thing again. Well, look at this. It says non-real answer. If I pull up that equation again and say, okay, well, let me try negative 100 minus what's it going to do? Well, again, it tells me that there's not a real answer. And that should make sense because we see it, there is no real solution to this problem. So why is this happening? Well, the only reason we would get a non-real answer is if we take the square root of a negative. The square root of negative 4, for example, does not exist. There is no solution, no real solution. And that's why we're getting this non-real answer. Under our square root, we have 100 squared minus 4 times a times c, which if you do that in your calculator, 100 squared minus 4 times negative 16 times negative 190, you get negative 2160. So this is equal to the square root of negative 2160. And you can't do that. You don't get a real answer if you do. Now there are such things as complex numbers, but that doesn't make sense in this problem. This is not a real solution. And math has its way of telling us. Usually we'll end up with this negative under the square root sign when a real answer doesn't exist. But it's important to understand logically why that is the case. So it's at most you can have two possible answers. You can have no answers. So zero solutions, the quadratic formula will have zero solutions when you have the square root of a negative number. You'll have two solutions if you have the square root of a positive number. And guess what? You can also have one solution. And how would you get just one solution? Well, that would be if you end up with the square root of 0. What kind of solution would that correspond to? Where along the vertex, excuse me, I think I just answered the question. There's only one point or one y value that's only achieved one time, and that's either the minimum or maximum. That would be a case where you would have one solution. Lastly, let's just mention briefly domain and range. Now, any problem that deals with quadratic equation we can solve using the quadratic formula. We just have to get it into the 0 equals ax squared plus bx plus c form. Doesn't matter what we have to subtract from the left-hand side, we just have to make sure one side has 0, the other side has the quadratic. Okay, well, for domain and range. For domain, if you're not dealing with practical domain, let's just go back to the height of the object and just call this generically y and x. Well, in that equation, y equals negative 16t squared plus 100t plus 10, you can plug in any number you want for t. Doesn't matter. You can square any real number, you can multiply any real number by negative 16, and you can multiply any real number by 100, and you can add together any real numbers. So the domain would be all real numbers. In other words, negative infinity, not less than or equal to, is less than x. Remember, we can't ever be equal to infinity, so we always would just say negative infinity less than x less than positive infinity. And then the range, well, we don't have just any y value, we have a maximum. So y has to be less than or equal to our maximum, which in this case was 166.25. And well, it goes down forever. So our minimum value would be negative infinity, is less than y, less than or equal to 166.25. Practically speaking, we'd probably make our domain range a little tighter. Of course, our domain probably would be from 0 seconds until that object hits the ground. So practical domain would be time is between 0 and, what do we say, 3 point, I think of what we had exactly, 6.45 seconds, I think, was when the object hit the ground. And then in reality, the height was no smaller than 0. It reached a maximum of 166.25. So these are the practical values. This is the mathematical domain.